Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 7, where we will solve a problem based on linked list, and the level of this question is going to be easy. The name of this question is reverse linked list. You will get this question link in description, and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So this is our question on LeetCode. Let's read it. So given the head of a singly linked list, reverse the list and return the reversed list. So question is pretty straightforward and pretty simple. We are given a singly linked list and we have to reverse it. And then we have to return the reversed linked list. And here are some of the sample test cases. So let's analyze this by taking some examples. So let's say we have a linked list which look like this. We have 1, then 2, then 3, then 4, and then 5, and then it is null. Okay, and the head of this linked list is here. So what we have to do, we have to reverse it, right? Then the reversed linked list would look like this: 5, 4, then 3, then 2, then 1, and then null. Okay, and the head of this reversed linked list should be here. So we have to return this. Reversed linked list, right? We do not need to return technically the linked list. We just need to return the head, right? We just need to return the head of this reversed linked list. Okay, now let's take some other examples. Let's say we have something like 5, 1, 8, and 12, and then it is null, and the head of this linked list is here. So what we have to return? We have to return the reversed linked list. So it will look like this. It will have 12, then 12, then 8, then 1, then 5, and then null, and the head will point at this node, right? We just need to return the head. Head pointer of this reversed linked list. So I hope the question is clear. So now let's analyze and let's think about how we can solve it. So let's take another simple example. Let's say we have 1, 2, 3 and null, right? This is our linked list, right? This is our linked list which we got in our input, right? And we have to reverse it. Now instead of thinking about reversing a linked list, let's think of if we would have given an array, and if the question says to return the reversed array, then how we would have solved this problem, right? So let's say we have an array which look like this: 1, 2, and 3, and we want to reverse it, right? We want to return the reversed array. We need to return the reversed array. So our reversed array would look like this: 3, 2, and 1, right? So this is in terms of array, right? Now come back to our initial main problem. This is our linked list which we have got, right? And we have to return the reversed linked list. Then the reversed linked list would look like this, correct? It would look like this, and the head pointer would be pointing at 3, correct? Now can you see a similarity? Between this particular part and this particular thing? It is nothing but the array, and this is nothing but the linked list. But there is a very big similarity in between them, right? What it is? The data is same. So here we have 3 first, here also we have 3, then we have 2 here in the array, and in our linked list also we have 2, then we have 1 in our array, and here also we have 1 in our linked list. So we can clearly see that data is same, right? Data is same in both in our array and in our linked list. So this is where we get the intuition. This is the point where we get an idea of how to reverse a linked list with the help of an array, right? So let's come back to the same example. We have 1, 2, and 3, and then we have null. Here is a head pointer. So just think of, can we convert this linked list into an array? You will say, yes, we can probably do that. So let's say this is our step number 1 where we convert our linked list into array. So now it will look like this, right? This is our array. Okay, now second step, can we reverse this array? Can we reverse this particular array? You will say again, yeah, it is pretty easy and simple. We can reverse it. Then the reversed array would look like this. This is what? This is our reversed array. This is our reversed array. Okay, now the third and final part. Can we convert this reversed array into a linked list? Can we reverse it? So the answer is yes. Yes, we can reverse it. So yes, we can convert it into a linked list, right? We can convert it into a linked list. So after converting this particular array into a linked list, it would look like this. Firstly, we have this 3, then we will have 2, then we will have 1, and then we will have null, and the head pointer would be pointing here, right? Would be pointing here, and this is nothing but this is our reversed linked list, which we wanted, right? So we will just return the head of this reversed linked list, and that's solved. Our problem is solved, right? So these are the 3 steps. These are the 3 steps in which we can solve this problem. The first step is to convert this linked list into an array. The second step is to reverse this linked list, and the third step is to make a linked list, right? The third step is to make a linked list out of this array, right? Out of this particular array, we have to make a linked list. Okay, so now let's do a quick dry run, right? Let's do a quick dry run. So let's say our array looks like this. We have 1, 2, 3 and null. Then we made an array, and array is like 1, 2 and then 3, and then we reversed it, and after reversing it is like 3, 2 and 1, right? Now the most important part comes. We have to convert this. What we have to do? We have to convert this into a linked list, right? So how we will do? So at first what we will do, we will create a node with the value -1, and its next pointer will be pointing to null, right? And we will call it as our answer head. And we will also use one more pointer named as current, and it will be initially pointing to this, our answer head. Okay, and then what we will do, we will traverse in this particular array, right? In this particular array with the help of a loop. So let's say these are the indexes. So at first, let's say we are running a for loop from I is equal to 0 up to n in this particular array. So initially I will be pointing at this index, right? So now what we will do, we will make a node with this value, right? Okay, so let's say we made a node with this value 3, right? Now what we will do, we will connect this 3, or we'll connect this new node with the previous one, So what we will do, we will connect it. So we will connect it like this, right? And when we create a new node, initially it have null in its next pointer, right? Now after connecting it, what I will do, I will update this current. Now my current will point at this node, right? Okay, now the I will get incremented, and now I will point to index number 1. Okay, then what we will do, we will do the same thing. We will see what is the value present at this index. It is 2. Okay, so make a new node with the value 2, and its next pointer will be pointing to null by default. Okay, then what is the next step? Next step is pretty simple. We have to connect this current node and this newly made node. So we'll connect it with the help of the next pointer. Okay, and after that my current pointer will point at this particular new node, right? Then again my I will get incremented, and now it will point to index number 2. We will see what is the value present at index number 2. It is 1. So we will make a new node 1, and its next pointer will be pointing to null by default, right? What's the next step? we have to connect this node and this node. So we will connect it using our next pointer, and then we will update this cur. So now my cur will start pointing to this particular node. Okay, after this I will again get incremented and it will come out of loop. Now we can see that this is nothing but our answer. This is indeed our answer. But what we have to return? We have to return the head, right? We have to return the head of this newly linked list, right? So the head, right now the head is here. Right now the head is here at -1, right? But our answer should look like this, right? 3, 2, 1 and null, correct? So instead of returning this, like instead of returning answer head, what we'll do, we will return the next of the answer head. So what is the next of the answer head? It is nothing but this 3. So we will return this node as a head of our answer, right? We will return this node and this will be our reversed linked list. Now let's think of how we are going to code this, right? So we need an array, right? So we will create an array, or we can create a vector as well. This is our array, right? Then what's the second step? We have to, what's the first step, right? It is the first step indeed. What's the first step? We have to convert our linked list, right? Our linked list into an array, right? And for converting it, we have to traverse. Into our linked list. So how we traverse? It is pretty simple. I hope you know this. So we'll create a new pointer named as temp, which would point at the head of the linked list. Then we will write while this temp is not equal to null. What we have to do? What we will do? We will take the value which is stored at this index. What is the value? Value is 1. We will just store it into our array, right? Into our array. So we'll write not answer. The name of our array is ARR. So we will write ARR dot pushback temp value, right? Temp val. So what it says that the value which is present at this particular node, just put it into my answer variable, right? Now after doing this, what we have to do? We have to increment this temp, right? We have to move it to the next node. So we'll write temp is equal to temp next, right? So this was our first step, right? This was our first step where we have converted our linked list into our array, right? Into an array. What's the second step? Second step is also simple. We have to reverse it. So to reverse, what we will do in C++, it is pretty simple. We will write reverse of ARR dot begin and ARR dot end. So now it got reversed. What's the third step? We have to convert this reversed array into a linked list, right? So for that, what we need two variables, right? We need two pointers. So we will write node asterisk answer head, right? And it will point to a new node. Having value -1, right? And then we will make a current cur pointer which will point to our answer head, right? Then we will run a loop for int I is equal to 0 up to n, where n is nothing but the size of our array, right? It is nothing but the size of our array. Okay, now what we have to do? We will get the data, or we'll get the value. So let's write data. Int data is equal to ARR of I. So we got the data. From, so let's say this is our array. So by writing this, we are getting this data, right? 1, 2, 3. These are the data. So we get this data. Now what we have to do? We have to make a new node, right? We have to make a new node out of it. So we will write node asterisk temp. Now instead of temp, let me just write it as new node, right? New node is equal to new node data, right? So what this line will do? It will create a new node with this particular data, right? Now after making a new node, what we have to do? We have to convert it. We have to connect it. So now we will write connect it to the next of the current pointer, right? So we will write cur next equal to new node, right? And after this we will update our cur pointer. So cur will go to the next node. Cur is equal to cur next, correct? And after doing this, what we have to do? After doing this, it is pretty simple. We have to return our answer heads next, right? Very importantly, next. So this is our code, right? This is our code for this particular approach. And now let's analyze the time and space complexity. So if we think about the time complexity, then we are running a loop here. So the time complexity will be big O of n, where n is nothing but you can say the size of our linked list, correct? Then we are using this reverse. So at max it will also take big O of n, right? And then this is a for loop. It is also running for O of n, right? It is also running for O of n. So you can say that the approximate time complexity is big O of n, and the space complexity is also big O of n, right? Now why the space complexity is big O of n? Because we are using an array. Right? So I hope this particular approach is clear into your mind. Now let's code it up fastly. Okay, so what's our first step? Our first step was to create an array. Not to create an array, it was convert our linked list into an array, right? The spelling of convert is wrong. Let me correct it. convert, right? So we have to convert our array, convert our linked list into array. So for that, let me just create a vector named as arr, right? And here the name of the class is list node, right? It is list node. But in the code, or you can say in the dry run, I was here using node asterisk. So here I assumed that the name of the class was node, right? So but in our code, but at LeetCode, you can see that the struct or the class is, the name of the struct or the class is list node. So instead of using node, we will use list node, right? So we will make list node temp as, and it will initially point to head. Then we will write a loop. We will run a loop that while this temp is not equal to null, just put the value into our answer, not answer, into our arr, right? Into our array. So we will write temp val, right? So what we are doing here, we are just putting the value present at this particular node into our answer variable, and after that we have to write temp is equal to temps next, right? Because we want to move the temp pointer to the next node, right? So after doing this, what is our second step? So our second step is to reverse, right? Reverse our array, right? So for reversing our array, it is very simple. We'll write reverse arr dot begin and arr dot end. Now after reversing, what is our step number 3? Step number 3 is to convert the arr into a linked list, right? And for doing that, what we need two variables, right? Or rather you can say two pointers of list node type. So firstly is our answer head, which will point to a new node, with the value as -1. Then we also need one more pointer named as current, which will point to our answer head. Then what we need to do, we need to run a loop I is lesser than arr dot size and then I plus plus, correct? Here what we have to do, we have to get the data. So the data would be nothing but int data is equal to arr of I. Then we need to make a new node, right? We need to make a new node. So I will write list node asterisk new node is nothing but make a new list node with this particular data, and then we have to we have to connect it, right? So we will write cur next is equal to new node. So now it is connected, and then we will write cur is equal to cur's next, right? And after doing this, we can just simply return answer head next, right? So I think this is done. So this was our first step, where we had created an array or created a vector, and the temp is initially pointing to head. Then we are basically traversing into our linked list, and while traversing we are just putting the value of that particular node into our ARR vector, right? After doing that, we are reversing our vector, or you can say we are reversing our array. And after that, we have used couple of pointers. First is the answer head, and second is the current. So this answer head is a pointer which is pointing to a new node with a value of -1, and current is pointing to our answer head. Then we are traversing into our reversed array, and then we are getting the data. We are making a new node with that particular data value, and then we are connecting it. With the current, with the cur pointer, and then we are just incrementing current to the next node, right? So we have written cur is equal to cur next, and then we are returning the next of the answer head. Okay, so now let me just run this and let's see it is running fine or not. Okay, so here you can see that all the three example test cases are accepted. So let me just submit it. Okay, so now you can see that this particular approach or this particular solution is accepted. Now let's think of, can we optimize this approach or not? So now let's think of how we can optimize it. So previously the time complexity was O of n and space complexity was also O of n, right? Now let's think, can we solve this problem without using this extra space? Can we solve it in O of 1 time complexity, right? So let's take the same example. It is 1, then 2, then 3, and then 4, and then null, right? Okay, and our head is pointing here. Then what should be our output? Our output should look like this. First we need to have this 4, then 3, then 2, then 1, and then null, right? And here should be our head pointer pointing, right? So this is what we need to make, right, out of this particular input linked list. Okay, so now we are very sure that we are not using any extra space, right? If we are not using any extra space, then we have to make some operations, right? We have to do some operations on the linked list itself, right? On the linked list itself, right? Now if you see these two particular nodes 1 and 2 clearly, so in this particular linked list 1 is pointing to 2, right? But in the output 2 is pointing to 1, right? Again see it very clearly with very focused, right? In the input linked list 1 is pointing to 2, right? But in the output, what we want, in the output this 2 is pointing to 1, right? 2 is pointing to 1. So somehow if we are able, right, let me just somehow if we are able to reverse this linking, right, somehow if I am able to make it something like this, 2 is pointing to 1, right? 2 is pointing to 1. Okay, now see this portion of the linked list, right? Here in the input, right, this 2 is pointing to 3, right? But in the output if you see 3 is pointing to 2, 3 is pointing to 2. So somehow if I am able to reverse this linking, and if somehow I am able to make 3 point to 2, right, then I can probably make my answer. I can probably do that, right? Similarly if you see these two nodes 3 and 4, then in our input in our input linked list 3 is pointing to 4, right? But in the output 4 is pointing to 3. In our input linked list 3 is pointing to 4, but in the output 4 is pointing to 3. So if I am able to reverse it, right, if I am able to reverse this linking, then it will look like this: 4 pointing to 3, correct? 4 pointing to 3. So now if I just remove all these things, let me just remove it so that you can see it more clearly. Okay, now see, right, in the answer our 4 is pointing to 3, and here also 4 is pointing to 3, right? In our answered linked list, 3 is pointing to 2, 3 is pointing to 2, correct? Here also you can see that 3 is pointing to 2, correct? 3 is pointing to 2. Now in the answer you can say that 2 is pointing to 1, 2 is pointing to 1, and here also 2 is pointing to 1. So we were able to reverse it in place without using any extra space, if we are able to reverse the linking, right? If we are able to reverse the linking, right? And then instead of having head at 1, our head should point to this, our head should point to 4, right? So this is the intuition, Now let's think of how we can code this, right? Let's think of how we can code this. So coding is again very simple. If you know the intuition, coding becomes very, very, very simple, right? So this is our linked list, right? This is our linked list, and this is our head. So initially we will use 3 pointers, right? We will use 3 pointers. First one is the current, which will point to our head itself, right? Second is a previous pointer, which will point to the previous node to the current node, right? Now initially when current is pointing to head, what is the previous node? Previous node is nothing, right? So let's say the initial value of previous is nothing but null, right? Nothing but null. So here is our previous, which is pointing to null, right? And we need one more pointer, which is next pointer, and next pointer will always point to the next node, of this current. Now what is the next node? Next node is this 2, right? Next node is this 2, right? So now this next pointer will point to this particular node, right? Okay, now what we have to do? We know that we have to reverse this linking, right? We have to reverse this linking. So now what I will do, I will say that the next pointer of the current, right? This is our next pointer, which is pointing to 2. I will say the next pointer of the current should point to the previous, Then how it will look? Now the next pointer should point to previous. Now what is previous? Previous is null, so it will point to null, right? Then what I'll do, I will increment, like I will do previous is equal to current, because now we have done operation on this, so now my previous will get updated, and now my previous pointer will point at this, right? Now my current pointer will come at the place of this next pointer, right? So now my current pointer is here, okay? Now again what I'll do, the next pointer of this current, right? The next pointer of this current node should point to previous. Where is previous? Previous is pointing, sorry, yeah, so previous is pointing to this node number 1. So now this node number 2 will point to node number 1, right? And where will be our next pointer? Our next pointer will be at here, right? Okay. So now what's the second step? Second step is to increment this previous. Now my previous should come and point to this node, right? So now previous will come at this particular node, and this current will go at the place of our next pointer, right? So instead of next, we will have current here, right? And now my next pointer will come here. Next pointer will point at node number 4, right? Okay. Now we will do the same thing. We will say the next pointer of this current should point to previous. So what I'll do, I'll point it to previous. Correct? Then what I'll do, I will say that now my previous should point at this node, at this node number 3, right? At node number 3. Now this current should, now the current pointer should move one ahead, right? one node ahead. So now my current pointer will come here, right? Now my current pointer will come here. Let me just rub this. Okay. And where will be my next pointer? Next pointer will point at this null, right? Next pointer will point at null. Okay. Then what I'll do? I'll do the same thing. What it is? The next of this current node should point to the previous node, right? So now the next pointer will point to the previous. Where is our previous? Our previous is at 3. Our previous is at 3. Now my previous will point to this particular node, right? Previous will come here, right? And current will go to the next node. So now current will point here, right? Now once we know that my current is pointing to null, what does it mean? It means that we have successfully reversed our linked list. And what will be the head? The head is the node where my previous is pointing. My previous is pointing to 4, then 4 will be my head, right? If I write it clearly, then it will look something like this, and previous will pointing here, right? Previous is pointing here. So previous is nothing but the new head of this reversed linked list. So I hope the intuition is clear. If you have doubt, do dry run or by taking different examples, then this particular approach will get more clearer into your mind. Okay, so now I hope the intuition is clear, and now let's think of how we are going to code this. So firstly, we know that we need 3 variables, so we will initialize them. Firstly, we will have current, which will point to head. Then we will have a previous, which will point to null initially, and then we have a next pointer which will initially point to null itself, right? Then we will run a loop while the current is not equal to null, right? While it is not equal to null, and then we have to do something, right? So let's say that this is our linked list, right? This is our linked list pointing to null here, and here is our previous, which is initially pointing to null, and here is our current, and here is our next pointer, right? Okay, so what I have to do, I want that the next pointer of this current node should point to previous, right? So let's say this is the next pointer of the current, right? So initially it have the address of 2, right? Instead of having the address of 2, I want this to point to previous. So I'll just remove this and I will write previous here. So now this next pointer will point to my previous, right? So for this, what I'll write current next is equal to previous, right? Okay, but what if we do not have next here, right? Let's say we do not have next pointer here. Then if you see this linked list clearly, our current pointer is pointing here at this particular node, right? Now can I move to this next node? You will say no, I cannot, because the next of the current is pointing to previous, right? That's why it is important to put next pointer here before doing this operation, right? Before doing this operation, it is important to update our next pointer. So therefore, before writing this, we will write next is equal to cur next, right? So that we will store the next of the current node into our next pointer, right? Then we just have to update our variables, update our pointer. So in the previous, I will write current, I will store current, and in the current, I will store my next pointer. And after that I can simply return my previous, right? Because this previous will hold the head of the newly reversed linked list. Okay, so this is our code, and the time complexity is very simple, O of n, because we are using a while loop to traverse our linked list only once, right? And we are using some couple of pointers, so space complexity is going to be O of n, like it is going to be O of n or constant. So this was our code. Now let's code it up on LeetCode fastly. Okay, so now we are here on LeetCode, so let's code it up. So firstly we need a couple of pointers. First one is the current, which will point to head, right? Then the second one will be my previous, which will point to null, and then third one will be my next, which will again initially pointing to null. Then I will run a while loop. I'll write current while current is not equal to null. So very first step is to store the next node in our next pointer. So I'll write next is equal to cur next, right? Then what we need to do, we need to update our cur next, right? We need to update our cur next. So I want my cur next to point to previous, right? Then I just need to update my previous pointer. So I will just store the value of current into my previous, and similarly I will update my current node as well. So now this current will have the address which is stored in this next pointer, right? After doing this, we just simply need to return our previous pointer, right? So this is the code. Code is pretty simple, pretty clear. So let me just run this. So now you can see that all the 3 sample test cases are accepted. Now let me just submit this. Okay, so now you can see that it is accepted successfully. So this was all for day number 7. This was all for this video. We will meet again tomorrow with new question. But if this video was helpful to you, if you have learned something from this particular video, then make sure you like this video, you do a comment. If you have any particular approach, comment it please, and make sure you subscribe this channel so that you get these type of content, this type of videos regularly.